right, so get your notebooks out. Those of you at home do the same thing. Get your notebooks out, right? Get something to write this information down. Can I get you to like zoom in and stuff when I need to? Okay. This is for Dexter and Kimberly since you can't make it today. Hope you feel better, Kimberly. So get your notebooks, get your notebooks. All right, so today we're gonna talk about gas furnaces, right? That's one of the main 6 pieces of equipment that we talked about that's gonna be on your final, right?
Look, this was.
And this is the inside of one right here. It's about, stands about yay tall, about this wide, one of the major 6 pieces of equipment, okay? This goes inside the house, it's usually installed inside the house.
I don't see that inside my house.
You know, well, sometimes in an attic,
Or a basement.
crawl space,
Oh,
basement,
I
yeah,
think-
closet
I
sometimes.
think it's in the attic.
You do,
I think it's
yeah.
in the attic.
A lot of times they put them in the attic. Anybody know how many volts this thing operates off of? No,
120.
120. So out of those 6 pieces of equipment I told you about, the furnace is the only one that we're gonna talk about that operates off 120 volts, okay? 120 volts. So if I ask you about any of these components, how many volts you think it runs off of, if you say 240, no, right? This is
But
100.
isn't everything just 120 besides the?
No, everything else is 240.
Yeah, 240.
Now, the package units, they can be more voltages and stuff, but air handlers, heat pumps, condensing units, all that, 240. Furnace, 120, okay? All right, so what we're gonna do is I'm gonna step you through the sequence of how the gas heat works, okay? There's 6 things. So start with number 1. Put at the top of your page, put gas heating, okay? And they go in order. Number 1. Anybody happen to know what I call this?
Combustion fan motor?
Yes, it's a
Like
combustion motor. That's exactly right. Combustion motor. They also call this, and write this down, an inducer draft motor, okay? INDUCER, inducer draft motor. You'll see it abbreviated IDM, or sometimes just CM for combustion motor. So if I ask you questions about this, as long as you tell me one of those answers, I'm okay with it, okay? Cool?
Mm-hmm.
So whatever you want to tell me, inducer draft motor or combustion motor, I'm good with it, okay? So this thing spins, right? It's a motor. Is this a load or switch?
Well,
It's a load. It takes power and it consumes that power to operate. Now, how many volts do you think this operates off of?
120.
120.
You're so smart. Look at those colors. They're black and white, right? 120 volt, write it down. 120 volt combustion motor, okay? So actually, let me start here first. Backing up a little bit, just to make sure you understand the process. You don't have to write this down. I'm just gonna ask you this because we've already been through this. What do we call this? Thermostat.
T-stat.
T-stat for short, okay? T-stat. So this type of system, we're doing gas heat and straight air conditioning, right? So that control wiring, remember the control wiring that we did on the thermostat? Tell me the terminals that what wires we wired and what were they?
White was yellow.
White, what
Yeah.
else?
Yellow.
Huh? Yellow? What else?
Blue.
Yeah,
Common.
that was a wire color, common. Common. What
R
else?
for power.
R for power, 24 volts, I love it, hot. And what's left? One more thing.
Green.
Green, what was that for?
Fan.
The fan, the indoor blower motor, right? Blower motor. That's common, right? What were these 2 for? What did that turn on and off?
W was heat and
Heat, yeah.
yellow was cooling.
Perfect. Heat
And cooling.
and then cool, right? So, talking about gas heating, when we turn this thermostat on heat, and we raise the temperature up above the room temperature for this thing to come on, remember Remember, this is a switch, right?
Mhm.
What's gonna close here? What two wires are gonna close together?
The
Red to what?
Black or white.
White. Red to white, because it's gonna call for heat, right? So it's gonna go from here and close to W to call for heat, right? So then that 24 volts can go back down to this furnace and turn on the heat, okay? Now, when it comes back down to the furnace, that signal comes down and hits this control board on that white, that W right there, see it?
Mhm.
So that tells this board, let's turn on the heat, okay? So this board is smart. It is gonna step through this sequence for us and turn these things on in order, okay? The first thing it's gonna turn on is what?
reference.
The combustion motor, right?
Mhm.
Okay, that's the first thing that's gonna happen. Now, after this thing turns on, and it spins, right? Gets 120 volts.
Mhm.
Number two is, does anybody know what this is, by chance? It's called a pressure switch. This is a pressure switch. This one's got just two wires on it. Power goes in, power goes out. A switch is not a load, it just lets power through, right? Okay. So this pressure switch, its job, oh, let me tell you what this job is. This inducer draft motor, combustion motor, its job, this one looks a little different, but that's the combustion motor right there. See that little wheel up there?
Mhm.
So that thing starts, its role is when this gas, these are where the burners are, where the flames actually burn right here. There's three of them, see it? When gas is released, this sucks that gas into the heat exchanger, sucks it in there so it can burn. If you didn't have this thing running and you release gas would just be pouring out all over the place. And that's dangerous, right?
Mhm.
It's gotta pull that gas back into that heat exchanger to burn properly, okay? That's what this thing does. So write it down, put, pulls gas into heat exchanger. That's what this thing does, okay? Pulls the gas into the heat exchanger. It does a little more than that, but we're just gonna leave it simple right now, okay? That's its role, that's what it does. Pulls gas into that heat exchanger. So then the pressure switch job, see this tube?
Mhm.
Mhm.
Slides on here. See it? This other end. Actually goes on to your combustion motor right there. See that? So this job is to prove that this turned on. This pressure switch proves that this is running because it's gonna read pressure. When this thing runs, it's gonna close the circuit, okay? Now, put pressure switch is normally open. If you check this with an ohm meter, check resistance, it would be open right now, okay? When that thing turns on,
Close.
it closes and proves, yep, it's running, we're good, we can go to the next step. That's what this does, okay? How many volts do you think goes through this switch?
24.
24 volts, very smart. Write that down, 24 volts. So, number three, the next step. This thing starts running. This thing proves that it's running. Next thing that happens is this little sucker right here. Now that's just a bracket that holds it, but this thing right here, does anybody know what this thing is?
Flame sensor?
You're close, not a flame sensor, not yet. What do you think this thing does? It's got two wires on it. This is a hot surface igniter. This is an igniter, okay? When this thing gets power, this one gets cherry red, super hot, right? Hot surface igniter. Sometimes we abbreviate it HSI for short, okay? Hot surface igniter. How many volts do you think this thing gets?
24.
You got two choices really. It's either gonna be 120 or 24. Now this thing gets really hot, so it probably needs more voltage to get hot, doesn't it?
120.
This gets 120 volts. Write it down, 120 volts, okay? Because it's gotta get really hot. Now, if you remember on your final exam question, there's 3 different types of igniters. This was one of them. Do you remember the other 2 that you wrote down without looking, that we talked about?
Or,
Spark, yes, one Sparks. You should know that, you went up there and did it on the roof, right? You tested the spark on that rooftop unit. That's one, and there's one more that are, that's common, well, it's not common anymore, but it used to be. Standing pilot. You don't have to write that down. Standing pilot is where that flame burns all the time. You're burning gas all the time, that's very inefficient, right? So they don't do that anymore. The only time you'll see that is like on water heaters, okay? But just know, for almost all of your residential furnaces, it uses this type of an igniter, okay? Spark is usually mainly just on your rooftop units now, okay, mainly. So this gets 120 volts, goes cherry red. This is the step number 3, okay? Now, if you have your igniter lit up cherry red, what do you think is going to happen next? Why is that getting cherry red? Why is it getting hot? Why is it getting red? What's the purpose of that? It's to ignite the gas, right? It's to ignite the gas. Remember the 3 things we need for combustion? We need
Spark.
oxygen,
spark.
Ignition.
we need an igniter, and we need the fuel, right? This is called, this is number 4, gas valve. This is what allows the gas into the furnace, okay? So, how many volts? Is this a load or a switch?
Load.
It's a load. How many volts do you think this gets? You got a 50-50
20.
shot? Nope, actually this is 24 volts. 24 volt gas valve right here. Okay. So that thing gets really red hot, and then it sends power to this thing and opens and lets the gas through, okay? This just opens the gas, that's all this thing does, okay?
It allows it into the furnace to start with.
Uh-huh, yeah, so what it does is, if you look at this thing a little closer, this thing turns on. Over there, there's your pressure switch right there. See that little tube that goes back and proves that that's running. Now this you can't see real good, but your igniter, see these 2 wires that go up? That's the part that gets cherry red. Once that gets cherry red, there's your gas valve. It opens that gas and lets that gas pour through here into those burners right there, okay? Now, the next piece is extremely important.
Is it this?
This, those are important, but this is number 5. This right here, this is a bracket. Do you notice this only has 1 wire on it?
A bracket?
No, it's not the bracket. This right here, you said it earlier. This is a flame sensor. It's only got 1 wire on it. So this is kind of unique. This is not really, I'm not going to consider it a switch or a load really, okay? But we did talk about this. This is a rectifier. And we know that a rectifier, because it's on our final exam, converts AC power to DC power, right? That's what a rectifier does. Sometimes they call this a flame rectifier or just a flame sensor, okay? This is very important because we have to prove that that gas ignited and we actually have a flame present, right? If we don't ignite that gas and we just start dumping gas out and we have no way to prove it, that's dangerous, right? We'd just be dumping raw gas all over the place and we blow the house up. So this proves that that gas ignited and there's a flame present, flame sensor, okay? So what the board does, this board right here, it sends some voltage to this flame sensor. And then once the flame hits it, it rectifies that AC voltage back to a DC voltage to this board, and the board says, hey, we got DC voltage, we got a flame, we're good. We're safe, continue to run, okay? That's what that does, proves flame. Make sense?
Mhm.
Cool, easy peasy. So once we do all of that, the last thing in sequence that has to run is our blower motor. This is our blower motor. You know this blower motor, this is when you put your hand over the vent, you feel air coming into the house, right? That's the last thing that starts. That's number 6, the blower motor starts. How many volts is this?
20.
240.
120 volts. Good job. So small. 120 volts, okay? Is this a load? Yeah, it's a load.
Mhm.
Absolutely, it's a load, right? This pulls more power than all that stuff combined, okay? So, those are your 6 steps for gas heating. Now, there's some other switches, they're switches, not loads, they're switches, that are extremely important in the furnace. I'm not really putting it in the sequence of operations, but if these are not good, none of that will run, okay? These are called limit switches. Now just don't put that as number 7, just put it down below there. Put limit switches and underline it, because these are very important to the safety of that furnace, okay? These are limit switches, and then I got a couple of different types of limit switches here, and we're gonna talk about each one of them, okay? First of all, what do you think they're measuring?
The heat.
The heat, temperature, these are temperatures limits, right? And we know our symbol for temperature, we know this, what it looks
It's
like.
the little.
Yes, yes. So that, if you looked at a schematic, it would look something like that. If you looked at a schematic, that's what it would look like on your schematic. So if this thing got too hot, these are all about if it's getting too hot or not. If it gets too hot, it's gonna open the circuit, shut all that down, okay? So you're safe. These are temperature switches. That's the one we blew up, you gotta remember that. It's got a mark.
I think it went away.
Thank
So
God.
then, it's like, they went away.
That's good. So, the first one I'm gonna tell you about is this one, okay? This is called a rollout switch, okay? If you look at this, it's got a little reset button on it. That little red reset button, okay? So if this thing trips, if this gets too hot, it's gonna open, and somebody's gonna have to go and reset it to get it to close back and make your furnace run again, okay? There's a reason why. So did you write down rollout switch?
Mhm.
Okay. Do you know how many volts goes through this?
24.
Yes. So smart. 24 volts goes through it, okay? So the rollout switch is there. If these flames don't burn back inside of that heat exchanger, if something causes those flames to roll out, wow, that's what they call this, don't they? Rollout switch. If those flames roll out back this way, this thing senses it and shuts it off. Uh-oh. Are we still good? Okay. Let's see if we can get it back on there. There we go.
Man, use your other hand.
There we go. Good? Okay. You were just trying to zoom in for me. So if those flames roll out and they're not burning back inside there like they're supposed to, this thing's in place to shut it down, because if those flames roll out, you can set the house on fire, right? And that's why they make this a manual reset, because they want a technician out there to figure out why in the world the flames rolled out, because that's extremely dangerous, okay? If these things trip, something bad's happening, okay? You need to take this very seriously, okay? The other kind of limit switch, we're gonna call this a high temperature limit. Write that down. This is a rollout. This is a high temperature limit. This measures the air temperature going through the furnace, okay? This measures air temperature. You know, when your blower's running and it's blowing that heat through, if it's getting too hot in there, it shuts it off. Because if it gets way too hot, again, you can have problems with burning your house down, okay?
What was that? Don't burn that down.
I almost burned my house down too.
And we burnt the house down with this one, didn't we?
Yeah.
Mm-hmm.
So if you look at this really closely, you can see the contact. You can see the switch right there. It's open, see it? These two pieces of metal, they close together, and we blew it up. Me and you. See that? That's the contact right there,
Mhm.
and it's open, see that? The two pieces of metal are not touching. That is the switch.
Mhm.
If it gets too hot, I'll show you, and then I'll show the camera. See that contact right there?
Mhm.
It's open. How's that look? Can you see it in here?
Yeah, it works.
So that contact's open right now. We overheated it and just blew it up, okay? So this actually goes inside the furnace and mounts flush to the piece of metal. You don't see this. This is stuck inside of the airflow. And as air goes through there, let's say this blower quit working, and you don't have any air blowing through there, and you got the burners running, that thing's gonna get extremely hot. That's why this is here. Or your filter's stopped up. You're not moving enough air through there. This senses that, opens the circuit, shuts it off. Now this one will automatically reset once it cools off. This one won't, because we totally fried this one. But this one will cool off and close back down and try to redo it again, okay? So these are very important. Now your furnace can have several of these on it. You could have 5 or 6 of these on it. Some manufacturers put them all over the place because they want to be extra safe, right? Some of them you'll only find maybe 2 or 3, okay?
Mhm.
But if these are open, if these limit switches are open and it calls for heat, none of that will ever start. This board is so smart, most control boards have a little light on here. It'll flash you a code. You count it. 1, 2, 3, 4. 1, 2, 3, 4. You look on here, 4, high limit switch open. It even tells you. Okay, so this board's very smart. It'll also tell you if this pressure switch isn't closing. It'll tell you. It can't tell you everything, but it can tell you. So if you walk up onto a furnace and you're having trouble, the first thing you do is count the flashes, and it will help guide you in the direction of what's wrong. Okay, that's the first thing you do is count the flashes. Okay, cool. Now. So all that makes sense to you?
Yeah.
Mm-hmm.
Now, why do they put the blower motor to come on at the very last step? Why not, when you call for heat, why doesn't it just come on right now as soon as that combustion motor
Because
comes on?
that takes more voltage than any other system.
That's a good answer, but that's
Wait,
not
what was
it.
the question?
Why do they wait to turn the blower motor on at the very end of the sequence? Why not just turn it on as soon as the heat calls? You know, the blower motor that you feel the air coming through the vent? Here's why.
Because wouldn't you need some of the cold to stay?
What?
Wouldn't you need some of the cold to be left behind? No?
You're on the right track. So if you turn the blower on before you start your heat and you're cold, you're gonna feel cold air coming through your vent until this thing heats up. So that's a comfort thing. You don't want the air coming into your house before this is heated up. So if you wait, turn on your burners and let it heat up a little bit, and then turn this on last, once the air starts moving into the house, it feels warm right from the start. Very comfortable. That's why they wait to the end on a gas furnace, okay?
I guess I'm-
Cool. So, to recap, pan it over here. First thing that starts, can you see all this? Cool. Pretty good? Okay.
Yeah.
First thing that starts is what?
The
Combustion fan.
Combustion fan
combustion
motor.
motor,
Yep. Second thing that's gotta happen is what?
pressure switch.
Pressure switch.
What is this thing doing?
It goes
It's
into
opening.
Normally open 24
And what is its job?
to make sure this is running.
Yes, to make sure that's running. So once that's made, then what happens?
HSI.
What does that thing do?
It helps at night.
Yeah, it goes cherry red, right?
Mm-hmm.
Once that's done and that heats up really good, what's next?
Gas
Gas
valve.
valve.
What does that do? What does the gas valve do?
It allows gas to go to the furnace.
Allows gas in, right? That's all there is to it. Once the gas was released, what's this do?
Flame
Flame
sensor.
Flame sensor.
Why is it there?
Convert AC to DC power.
But why is it there ultimately? What is its job? To prove that there's a flame.
Mm-hmm.
To prove that that thing lit. That is important. Write that down if you don't have it. This thing's job is to prove that there's a flame. It's a flame sensor, okay? And then once all that happens, the very last step, about 30 seconds to a minute later, the blower motor starts and pushes the air into the space, right?
Mm-hmm.
That's it. And these are limit switches, safety devices, make sure it doesn't overheat, okay?
So that
Any
one
questions?
doesn't
Pretty simple,
Yes.
right? Okay, you can cut this